Hello, fellow students. Welcome to Prince Osuechan Chemistry Tutoring page. Do you have difficulty in understanding chemistry concepts? Want to ace your exams while so depending on your understanding of chemistry? You have arrived at the right place. This channel simplifies complex chemistry topics into simple lessons, catering to high school, college, undergraduate, and other interested students. The goal is to make chemistry lessons enjoyable and understandable. Here is what you can expect. 1. Detailed tutorials on key chemistry topics, such as organic chemistry, organic reaction mechanisms, chemical reactions, and many more. 2. Clear explanation of complex concepts with real-world examples and application. And 3. Live questions and answers sessions, where you can ask chemistry questions and get personalized answers. Please join our growing community of chemistry fans. To ensure you never miss a new video, subscribe and enable notification because life is all about chemistry and make chemistry education a blast. Please subscribe to my YouTube channel at Weniswakem. Based on lecture 1, we are going to discuss organic molecules and structures. Life is all about chemistry and make chemistry a blast and make chemistry education a blast, according to Sir Paul Ness. As I said, you can subscribe to my YouTube channel at Weniswakim, or you can reach me on email prince.owusu@yahoo.com or LinkedIn Prince Owusu Echon. Based on organic molecules and structures, science stems from our natural curiosity about ourselves and the world around us. Thousands of years ago, people marveled at the sight of fireflies on summer evenings. Nature's colors and smells convey a diverse range of messages. Despite being blindfolded, we can distinguish between a pine forest and a seashore. We are amazed and we wonder, how does a firefly produce light? What substance contributes to the pine forest fragrance? What happens when summer green leaves turn red, orange, or gold in the fall? That's the question to ask yourself. Based on our study outline, we will look at the introduction to organic chemistry, the origins of organic chemistry, and we will look at molecules. What are molecules? Because people confuse themselves with molecules and compounds. We will look at that. Organic compound. We will look at characteristics of organic compounds, and we will come to our main topic, definition of organic chemistry and what is its importance. Introduction to organic chemistry. Chemistry's magic is evidenced everywhere we look. Millions of chemical compounds exist around us. Some of these compounds are found in our bodies. However, we are largely unaware of how these compounds work. To understand the meaning of organic chemistry, we must first grasp the concept of chemistry. Chemistry can be defined simply as the science that studies elements, compounds, and their properties. This branch of natural science is divided into three categories. 1. Physical chemistry, inorganic chemistry, and 3. Organic chemistry. So our main focus is on organic chemistry. Organic chemistry is the study of how carbon-containing compound reacts. Organic compounds are vital to life. Organic compounds include proteins, which serve as the structural and functional basis of living organisms, drug molecules, which are used to treat diseases, and petroleum compounds, which provide energy. Organic chemistry is primarily concerned with carbon compounds found inside or outside of living bodies or their derivatives. However, not all carbon compounds are organic. To illustrate, consider triazocarbonate 4 acid. I hope most of you people will know this naming. Triazocarbonate is how we go to name. We will look at that in our subsequent lectures. To illustrate, consider triazocarbonate 4 acid, which despite containing carbon, is inorganic. As a result, everyone must proceed with caution when selecting and identifying organic compounds. Organic is one of the most overused words in English. People frequently use it as a derogatory term in phrases such as, "Don't eat that, it is not organic." Why people say that? Of course, there is a precise scientific definition for the word. In science, organic can refer to a biological or chemical entity. In biology, it refers to anything alive or has lived. Non-organic is the opposite of organic. In chemistry, an organic compounds containing carbon atoms. The chemical meaning will be investigated and presented in this concept. The original definition of organic chemistry stemmed from the misconception that organic compounds were always associated with biological processes. You must know that not all organic compounds support life on Earth, but life as we know it is heavily reliant on inorganic chemistry. For example, many enzymes rely on transition metals such as iron and copper, and materials like shells, teeth, and bones are composed of both organic and inorganic components. Aside from elemental carbon, inorganic chemistry focuses on simple carbon compounds with molecular structures that lack carbon to carbon or carbon to hydrogen connection. That is its oxide, acid, carbonate, carbides, and minerals. Our next study outline the origin of organic chemistry. The science of chemistry, which studies matter and its changes, has its roots in our unquenchable curiosity about ourselves and the world. The French nobleman Anton Laurent Lavoisier provided clues about how chemical composition could be determined by identifying and measuring the amount of water, carbon dioxide, and other materials produced when various substances were burned in the air. By the end of the 18th century, two branches of chemistry were recognized: organic chemistry, which deals with matter obtained from natural or living sources, and inorganic chemistry, which deals with substances derived from non-living matter, such as minerals. Combustion analysis soon established that compounds derived from natural sources contain carbon, leading to the definition of organic chemistry as the study of carbon compounds, which is still used today. This development of chemistry has been instrumental in fostering an increased understanding of our world and our place in the world. What are molecules? Our next subtopic. Molecule is the general term used to describe any atoms that are connected by chemical bonds. Every combination of atoms is a molecule. A compound is a molecule made of atoms from different elements. All compounds are molecules, but not all molecules are compounds. Every substance is composed of molecules, which are collections of atoms. All molecules in existence are composed of approximately 100 different types of atoms. For example, a water molecule consists of 2 hydrogen atoms and 1 oxygen atom. We note this formula as H2O. A molecule of sulfuric acid contains 2 hydrogen atoms, 1 sulfur atoms, and 4 oxygen atoms. And this formula is A2SO4. These are simple molecules with just a few atoms. Most inorganic molecules are small. Here are some examples of inorganic substances and their formulas. We know carbon dioxide to be CO2, and salt, our normal salt is sodium chloride, that's NaCl, is sodium chloride, and our nitric acid is HNO3, or you can name it triazonitrate, 5-acid. Laughing gas, which is N2O, ammonia, which is Na3, and saltpeter. It is used in gunpowder, which contains KNO3. Carbon monoxide, which is a poisonous gas. This is a poisonous gas, carbon monoxide. Potassium permanganate, which is used in labs, in scientific lab. It contains KMnO4. And calcium carbonate, the chalk we used to write, that's CaCO3. Our next subtopic is organic compounds. What are organic compounds? Most atoms can only form small molecules. However, 1 or 2 can combine to form larger molecules. Carbon is by far the best atom for forming large molecules. Carbon can form molecules containing tens, hundreds, thousands, or even millions of atoms. Because of the vast number of possible combinations, carbon compounds outnumber all other elements combined. A single carbon atom can combine with up to 4 other atoms. That the maximum number of atoms that carbon can have is 4. We say it has a valency of 4. sometimes carbon atom will combine with fewer atoms. So this is the illustration of how carbon form bonds. The maximum number of bonds that carbon can have is 4. That's here is 1, 2, 3, and 4. With it, it may be the same element or atom or molecule or different, where R can be carbon, oxygen, nitrogen, sulfur, and halogens or other compounds or molecules. The carbon atom is one of the few that combine with itself. This means that the carbon atoms can form bonds with other carbon atoms. In other words, carbon can bond with other carbon atoms. This implies that carbon atoms can form chains. The chains can be linear or branched, and rings to which other atoms can be attached. This results in a large number of different compounds. These compounds are collectively known as organic compounds. Thus, organic compounds are carbon-containing compounds that have at least one CH or CC bond and may contain a few other elements such as oxygen, nitrogen, sulfur, phosphorus, and halogens. Organic compounds are classified based on how their carbon atoms are arranged and what other groups of atoms are attached. So examples of how carbon can be arranged, it can be in a linear form or branch form or ring form. In linear form, we can see a straight chain. See carbon, here we have carbon 1, 2, 3, 4, and it has a straight chain. For the branch, we can see a straight chain by it is branching in carbon 3. And for the ring structure, we can see all carbon form bond with each carbon. See, there is a ring structure. This is the ring structure. Characteristics of organic compounds. Organic compounds are covalently bonded, allowing for unique structures like long carbon chains and rings. Covalently bonded means there is a shared pair of electrons between atoms of carbon or carbon with hydrogen, nitrogen, or oxygen. Carbon atoms form stable covalent bonds, making them excellent at forming unique structures. Organic compounds typically melt, boil, sublimate, or decompose below 300 degrees Celsius and are less soluble in water than inorganic salts. They dissolve in organic solvents such as pure substance like ether or ether alcohol, mixtures like petroleum ethers and white spirit, or aromatic solvents obtained from petroleum or tar fraction. Solubility depends on the solvent type and the presence of functional group. A unique property of organic compound is that carbon valency does not always have to be taken up by other element atoms. Conjugated double bonds alternate with single bonds in chain. We can see carbon bonds For example, benzene. Benzene has carbon compounds, carbon and hydrogen compounds, and we can see double, single bond. That's the alternate, that double, single alternate with the single bonds, double, single, or single, double bonds. Now we are come to our main focus, definition of organic chemistry. Organic chemistry is the study of organic compounds, including their structure, properties, composition, reactions, and preparation. This can be done through synthesis or other means of organic compounds. The diversity of carbon chemistry derives the diversity of life. As I said, life is all about chemistry, resulting in an infinite number of living organisms made up of carbon molecules. Organic compounds are found in living things and formed over millions of years from dead remains. These compounds have resulted in a nearly limitless variety of living organisms comprising carbon molecules. Multi-carbon compounds have a vast range of applications in various products and life processes due to their unique properties. They are essential for various products, including paint, plastics, food, explosives, drugs, and petrochemicals. Their diverse shape and chemical reactivity enable various functions, including enzymes catalysts in biochemical reaction. The self-propagation of organic compounds is what defines life. Importance of organic chemistry. Why is organic chemistry important? That's the question. Organic chemistry is important because it studies life and all of the chemical reactions that occur during it. Organic chemistry is used in a variety of careers, including doctors, veterinarians, dentists, pharmacologists, chemical engineers, and chemists. Organic chemistry contributes to the development of common household chemicals, food, plastics, drugs, fuels, and in general, the majority of the chemicals found in everyday life. This is the end of lecture 1. Please subscribe to my YouTube channel at Oniswakim, or you can reach me on prince.owusu@yahoo.com or on LinkedIn, Prince Owusu Echam. Life is all chemistry, and make chemistry education a blast. Today's lesson, we have seen the introduction of organic chemistry, the origin of organic chemistry, and we have also discussed molecules and organic compounds, and also our main focus, which is on organic chemistry, the definition and its importance. Thank you.